I am Dan Olds. I've been an industry analyst since 2000 or so. Before that, I was with various high-tech companies, including Sequent, if anybody remembers that. That was my first gig in high-tech. Also including Cray, it's the last employee hired on the day that there was the buyout, Sun Microsystems, and IBM. Then I went out on my own. So what we're going to talk about today is high performance interconnects. This is something that we've studied as a company and have done some research around. And this stuff, at the first, you guys know this stuff. We're going to go through it pretty quickly. High performance interconnects, it is the high end of the interconnect, right? And that line is kind of around here. And you can see the top, 100 gigabits and faster, specialized stuff like Cray, like SGI, InfiniBand is in there, Intel's OPA is in there, almost exclusively is using MPI. When you get to the multiple racks, that's when you start to go for the faster interconnects, depending on what you're doing. Three types of HPIs, Ethernet. We know it, we love it, we use it all the time. It's Ethernet. We just don't use it for high performance computing as much anymore because, why? It's got the bandwidth, but it's got the latency. It's got a lot of latency. Proprietary stuff, primarily sold by your Crays, your SGI, now HPE, IBM, and a few others. Bull has one, but you got to purchase a system in order to get their interconnect, right? Intel is a new entrant into the proprietary interconnect because their interconnect is, well, proprietary. It's not open. InfiniBand is pretty much owned by Mellanox at this point. It's the highest performance based on the published numbers, 200 gigabits with HDR, 200 billion messages a second, 90 nanoseconds latency. We're going to dive into these a little bit more deeply. Like I was just saying, Ethernet, it's out there, it's loved, but look at the share, and these numbers are a little bit out of date in terms of top 500 list. There's no Ethernet in the top 50. There's damn little Ethernet, 1 or 2 in the top 100. And as the lists have gone on, I think this is as of the November list from last year, it's just gotten lower. OmniPath is coming on. This number's a little bit bigger now. It's there. It's in some high-profile installations. So more than a handful of customers and some big names in there. They have claims for bandwidth, latency, and message rate that are similar to 100 gigabit per second InfiniBand. And then InfiniBand, been the HPC market since the early 2000s. Lots of customers, lots of nodes. Now makes up, it's the largest single interconnect in the top 500. And it's, like I said, kind of synonymous with Mellanox. And you'll see that when you look at the top 50, it's either custom and proprietary or it's InfiniBand. There's not that much OmniPath, and like we discovered, no Ethernet. Same with the top 500, except you see that the InfiniBand is even larger over the others. Now we come to the discussion, the war that is kind of quietly raging. I don't know, it's turning into more and more of like a hockey fight. Onload versus offload. And we heard about this a little bit this morning. I'm just going to cover it again very quickly. Onload, main CPU, the CPU handles all the network protocols, all the network functions. OmniPath does this, Ethernet does this, also old PC servers, Unix systems, stuff like that. So everything connected with that network transmission is handled by the main CPU. Offload, different. Offload has specialized hardware with the switches and the adapter cards, etc., that handle all of that processing. So the CPU doesn't really do any of it, okay? InfiniBand does this, mainframes do this. They have a communications assist processors, and they have had for generations. So the network protocol load includes the link layer, right? For packet layout, packet forwarding, etc. Network layer, which adds the header, routes packets, transport layer, and then as they talked about this morning, MPI operations, right? That's other stuff that needs to be done in moving data around in a cluster. With offload, all of these operations are handled by the adapter. Onload, well gosh, it's kind of the opposite. Same stuff has to happen, but with onload, all of these operations are handled by the CPU. So all of this is load that's going on your CPU, and as we're going to see, it can be quite a load. It's not really a big deal when the cluster is small. And do you like what I did for the head node? Kind of lame? Okay. I thought that was pretty cool. It took me like 4 hours in Photoshop to do it. I've got to find exactly the right head. Yes, I did. Excellent. So in a small cluster, not a big deal. These messages are flying around, but when you got a big cluster, it's going to be a much bigger deal, especially when you start talking about scatter, gather, and other collectives that are going out, right? And think about what's happening to the head node when its CPU has to handle all of this communication flying back and forth. And the same thing with each one of these, right? It's the CPU in an onload situation is handling all that communication traffic, and depending on the application, it could take up a very significant portion of the CPU. And as node count increases, it's going to get worse for onload. And node counts have been increasing. This is from the top 100 average node count for the past 4 years there, 5 years. The other thing is that when you do something in hardware rather than software, it gets a lot faster. And that's the thing I do like about Offload is those ASICs that they're using to do all the protocol computation, do it pretty fast. In fact, very fast. One thing that at least some of the audiences I've talked to haven't really thought about is that MPI is not all that parallel. And if you're going to talk about a CPU, and I'm going to pick on Intel a little more, like Knight's Landing, right? Doing offload or doing onload communications, that thing's only 1.3, 1.4 gigahertz per second, and you're going to be limited to the lowest clock speed on your single core. And that doesn't have any bearing at all on offload speed. Driving on, the FUD war. Interesting here, this is from Intel. They're saying with EDR that just the cost of the interconnect is about 40% of the cost of the total cluster. Now, from the research I've done, it's typically around 15 to 20%. Do you guys pay 40% of the entire cost of your cluster for the interconnect? Anybody? Okay, just a couple of shaking heads out there. And it doesn't really pass the smell test for me. Prices in high tech typically don't increase over time for hardware. And the price points tend to stay the same. You're paying about the same for a very high-end PC today that you paid 5 years ago or 5 years before that. Same thing with a low-end server. The products get more capable, but those price points remain the same. These are some more numbers from Intel in a particular story that is referenced here. What do all these things have in common other than showing Intel an advantage? Well, what they have in common is a fine print. And what fine print it is. It was very small. I had to blow this up and retype a bunch of it. So let's deconstruct this a little bit. DAPL is a key. It's an Intel MPI mechanism in their version of MPI that doesn't really allow for offload operations, which makes it quite hard to have a level playing field with something that does offload. And this one I love. It's the catch-all. Software workloads used in performance tests may have been optimized for performance only on Intel microprocessors. At least they're up front with that. I mean, it's in a very tiny print, like 6 point, but it's there. I like that. This is the one that really kind of bugs me, though. What they're showing here is that with their onload, that they have about 65% CPU utilization when all cores are busy, right? What they're showing here for offload is 100% cores busy just doing networking stuff. So they're showing that their cores are taking about 60, 65% of the CPU power to do network communications. But on offload, it's 100%. So essentially, what they're saying, if this is true, is that 190 some odd systems on the top 500 are absolutely useless for compute because they're using InfiniBand. So that they're not getting any application performance on their CPUs at all. It's just moving data around and sending messages. I hate this kind of FUD because it's stupid. I mean, if you're going to come up with FUD, come up with better FUD than this. Come up with something believable. Well, what's interesting is that both Intel and Mellanox have benchmarked OPA at about 65% CPU utilization, right? When it's stressed. That's 65% of your CPUs that aren't being used for applications. They're being used to control the network. They're being used to send and receive messages. That's a pretty damn big penalty. So, FUD aside, here's the numbers updated for HDR. Intel OPA, bandwidth of 100 gigabits per second. Mellanox EDR is 100 gigabits per second, 200 gigabits per second with the HDR. Latency, pretty close, right? Latency is not the big determinant between these things anymore because this latency is getting underneath the latency that just comes with MPI. Message rate, Intel says 89 million per second, and that's dropped from 150 million per second in 2015, the claim. Mellanox is claiming 150 million messages a second and 200 million. Roadmaps. Very interesting here, the InfiniBand Trade Association has always been pretty upfront with the roadmaps, and they hit their number. 2017, going to come in with 200 gigabit. NDR, the next one, at 400, looks to me like it's going to be around 2019. I know there's people in the room that could tell me this for sure, but I don't think they will tell me, not without an NDA. Interesting thing is that there really wasn't a roadmap for Intel's OPA. There were some numbers floating around saying that they were going to have OPA 2 in 2018, but I just heard that that's been delayed until 2020. So that's kind of an ouch on that. Ethernet roadmap shows 200 gigabits per second somewhere in 2018, 2019. So when my company, OrionX, did the analysis of this, we do this kind of in a different way. You guys have all seen the Gartner Magic Quadrant charts? Yeah, right? Then there's also the Forrester Wave, which is kind of cool. Yeah. What we wanted to do was come up with a chart, and oh, what a chart it is. You're going to see it on the next slide. It's one hell of a chart. But we wanted something that would take into account the market, the customer, and the product. Market presence, trends, and then an overall average. And this is one that no one really takes into account, customer readiness. How ready are customers to adopt Ethernet? Well, they're pretty damn ready because damn near every one of them has it, right? How ready are they to adopt OPA? Not so ready because it's brand new. A little bit less ready than Ethernet to adopt InfiniBand, although there is a lot of knowledge out there and there's a lot of help out there. So then we also wanted to rank their capabilities, product capabilities, which is pretty standard, but also the roadmap of the vendor and how well they keep to that roadmap. And here's how they all shake out. We put this on sort of a spider chart. Isn't that impressive? You know how long it took us to come up with this? Months. Because we argued. But what it does show is how each of the vendors, how each of the major HPIs do according to our scale. And I think it shows it fairly well. As you can see the area here by the blue, that's InfiniBand. The yellow is OPA, or excuse me, yellow is OPA, and Ethernet is the brown. So, that was it. I got you back on time. Any questions, comments, concerns? Yes, in the back.
So on that graph at 4, you had something for those pretty smart customer needs.
Yes.
So what's in that?
Customer needs includes, and remember, this is just what we're studying for the high performance interconnect market. And it's how well these technologies and vendors fulfill customer needs. For instance, Ethernet's a loser for a high performance interconnect. Just way too much latency. Intel OPA was a bit closer to InfiniBand before, and that was before 200 gigabit came out. And before they kind of came up with no roadmap until 2020. So that's what we're trying to take into account there. And essentially, customers for high performance interconnects need really high performance interconnects. So it's hard not to give Mellanox and InfiniBand a 9 there because it's the highest performing interconnect out there. Doesn't take into account money, though. You know, it's close. It's very close, and the capabilities on here that, for instance, you'll see Ethernet scores a little bit better in capabilities, and it's because they do have high speed, they just have low latency, and they have a roadmap to higher speed. Intel didn't have that. It's, you know, you start to get a bit subjective when you drill down that far, but it's how we're trying to divide it out. We have, if you look on our website, we have papers written around this stuff that drills into it a little bit more. Other questions? Comments? This sure didn't do too bad. I mean, I got through it. So, not bad. Well, thank you very much. I appreciate the time.